Good morning, math wizards of Virtual Room 502. Welcome back to Eureka Math in the Morning with Mr. Leggett and friends. Let's look at our application problem. Chloe's dad partitions or sets apart his garden into 4 equal-sized sections to plant tomatoes, squash, peppers, and cucumbers. What fraction of the garden is available for growing tomatoes? All right, well, let's take a look at this then. Let's take a look and see what's going on. Let's make his garden. Chloe's dad. Okay, we'll break it into one section for tomatoes, one section for squash, one section for peppers, and the other section for cucumbers. So we have tomatoes here. Oh, and by the way, I'm sorry to say, copycats. Not sorry to say. We like being copycats. So go ahead and pause if you need to catch up. I'm just going to put initials here, not write them out. T for tomatoes. S for squash. P is for peppers. And C is for cucumbers. So we have tomato, squash, peppers, and cucumbers. All righty. So how much of this garden is relegated or partitioned for the tomatoes? Well, let's think about it. This is the entire garden. One whole, right? So what have we broken it into? Let's shade the tomato part. We know our denominator is 1, 2, 3, 4. And just like our number bonds, I know that's 1/4, 1/4, 1/4, and 1/4. 1/4 plus 1/4 plus 1/4 plus 1/4 equals 4/4, or 1 whole. So we can see here 1/4 of the garden is terrible S for tomatoes. So we had 1/4 for tomatoes, 1/4 for squash, 1/4 for peppers, and 1/4 for cucumbers, and we get 1 whole. So 1/4 was for tomatoes, 1/4 for squash, 1/4 for peppers, 1/4 for cucumbers. We can see that 1/4 of the garden is for the tomatoes, and 1/4 is for the squash, 1/4 is for the peppers, and 1/4 is the cucumbers. We'll take a look at it like this, just because we have a little bit of time. 4/4. Oops, that's a tiny one. 1/4, 1/4, 1/4, and I could barely fit that in there, but 1/4. 1, 2, 3, 4/4 equals 1, and the entire garden. All right. We are going to continue on with our concept development. No need to take a break. We can keep on working through this, I think. Or at least a couple of them. Don't you think? So let's go ahead and write this fraction. Once again, you are indeed cats of the copy nature. And we're going to start off with 1/2. So you write 1/2 as well on your whiteboard or scratch paper. Now, it's written in fraction form. What does the 2 mean? Well, think about that. 2 is the number of equal parts that the whole is cut into. So let's go back to our pizza today, and we cut it in half, right? So that represents the 2 equal parts. What does the 1 equal? Or mean, excuse me. We are talking about 1 of the equal parts, 1 of 2, correct? Correct. So let's continue on with some different shapes. And you can draw with me. We're going to draw one circle right here. And we're going to partition it into 3 equal pieces. I know they're not equal, but close enough. And then we're going to go like this. We're going to go over here and make it the same shape to the best of our abilities. But this time around, we're going to shade in 1. So what do we have here? What fraction? Well, we have 1/3, right? And we'll continue on and make another circle. Sometimes I put a dot in the middle there. Maybe make it a little simpler. And let's this time around shade in 2. So what do we have here? We have 2 shaded in, right? Out of a total of 3 equal parts. So we have 2/3. If I were to continue going, I'd wind up with 3/3 or 1 whole, correct? Yes. Let's take a look at another shape. You can all be copycats. And here we go. This is going to be a crazy shape. Crazy shape. And we're going to draw a diagonal line this way. Doesn't have to be exact. Diagonal line that way. Horizontal line that way. Vertical line this way. And I think we're done there. Yeah. So they're not equal. I mean, they're not equal parts, but for all intents and purposes, let's pretend they are. And I'm going to color in 1. So what do we have here? We have a total of 1, 2, 3, 4, 5, 6, 7, 8. That's our denominator. How many are shaded? 1. Some of you don't want to count the shaded part, but you have to count the shaded part to get the whole, right? So now let's make this shape again. It's a fun shape to make. I think it is. We'll draw a line. Let's draw a line down the middle, draw a line across, draw a line like this, and draw a line like that. Okay, so there we have it. And let's color in some more, shade some more. We'll shade 1, 2, 3, 4, and 5. Now, that's a little different from yesterday because yesterday we only concentrated on shading in 1, but now we're shading in multiple units. So what do we have here? 1, 2, 3, 4, 5, 6, 7, 8 total, just like before. But how many are shaded in? 1, 2, 3, 4, 5. So we have 5 eighths. Here was 1 8. Here was 5 eighths. Getting that? Because yesterday, this is what we did yesterday. This is what we're doing today. We'll do another one before we take a little break. And we are still indeed copycats, so make a tape diagram. We're breaking this one up into 4 pieces. There we have that, and we're going to shade 1. Now we're going to get a little tricky. Try to replicate this exact same shape to the best of our abilities. And go 1, 2, 3, and 4. Okay, so now let's shade in this one, and this one. Tricking you. What do we have now? Up here we had 1/4. But down here, what do we have? How many total units do we have? We have fourths, right? We did that yesterday. But how many are shaded? What's the numerator? 1, 2, 3. It's okay, we could skip 1. It's still showing 3/4, okay? So take a little break right now. Go get a drink of water. Use the restroom if you need to. Get a drink of water. A snack, pet the dog, feed the cat, tell mom and dad you love them, do some jumping jacks, do some sit-ups, do some push-ups, but get back here in 2 to 3 minutes for our final chunk of video. And if there's any time left, if it's still before 10 o'clock, you can come and join me